The universe is full of strange and surreal paradoxes that challenge our understanding of the world around us. From the mysteries of quantum mechanics to the mind-bending properties of black holes. The universe presents us with a plethora of phenomena that defy our intuition and challenge our perceptions of reality. This video lets you see some of the many things we do not understand in the universe and the strange and surreal paradoxes in what we think we understand. If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. Everything we know represents just 5% of the universe. What is the rest? Normal matter. Protons, neutrons, and electrons make up just 5% of the universe. Staggeringly, the other 95% is something we cannot fathom, see, or understand. We call it dark matter, which makes up 27% of the universe, and dark energy, which makes up 68%. But what are these mysterious components of our universe? Dark matter and dark energy are two mysterious concepts in astrophysics that scientists use to explain some of the strange observations that we make about the universe. Dark matter is a type of matter that does not interact with light or any other form of electromagnetic radiation. This means that we cannot directly detect it using telescopes or other instruments that rely on light, but scientists can infer its existence by observing its gravitational effects on visible matter, such as stars and galaxies. Dark matter is thought to make up about 85% of the total matter in the universe, but we still do not know what it is made of. It does not behave like any of the known particles that make up ordinary matter, such as protons and electrons. Some theories propose that dark matter consists of undiscovered particles that do not interact with light or other forms of radiation, while others suggest that it may be made up of exotic objects such as black holes. Dark energy, on the other hand, is a hypothetical form of energy that is thought to permeate all of space and is responsible for the accelerating expansion of the universe. Unlike dark matter, which has a gravitational effect that slows down the expansion of the universe, dark energy has a repulsive effect that causes the expansion to speed up. The exact nature of dark energy is not well understood, but it is thought to be a property of space itself, rather than a type of matter or energy that we can directly observe. Scientists believe that dark energy makes up about 68% of the total energy in the universe. How many dimensions does the universe have? To the best of our knowledge, the universe as we know it has 3 spatial dimensions: length, width, and height, and 1 dimension of time, making a total of 4 dimensions in space-time. This is known as the 4-dimensional space-time. However, some theories in physics, such as string theory, propose that there may be more than 4 dimensions, possibly up to 11 dimensions. But these extra dimensions are thought to be curled up or compactified, to be too small to be observed at our scale. This means that although they may exist, they are not directly observable, and their effects on the 4-dimensional spacetime can only be inferred through their influence on the physical phenomena that we can observe. These additional dimensions would help us unify the mathematical basis of the 4 fundamental forces of nature, including the strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. Do these higher dimensions exist? And if they do, is there a way for us to measure their presence, or will we forever be trapped in our 4-dimensional world? What if our universe is just one of a multitude out there? The idea that our universe is just one of many universes known as the multiverse theory is a popular concept in modern cosmology and physics. According to this theory, there may be many other universes existing alongside our own, each with its unique properties and laws of physics. If this is the case, it would have profound implications for our understanding of the universe and our place in it. For example, it could help explain why our universe appears to be finely tuned to support life, known as the anthropic principle. If there are countless other universes with different physical laws and properties, it would increase the chances of at least one of them being able to support life. The multiverse theory also raises questions about the nature of reality and how we define what is real. If there are many different universes with different physical laws, are they all equally real? Or is our universe the only real one? What is time? Time is one of the most difficult properties of our universe to understand. Researchers say that time is a measurable period, a continuum that lacks spatial dimensions. There seems to be an obvious direction or flow of time, and it seems we can't travel backward in time. Why are we trapped in the arrow of time, perpetually moving forward? Is the passing of time intertwined with the way our universe works according to the theory of the Big Bang? Time itself began together with the rest of the universe about 13.8 billion years ago. Does that mean that it makes no sense to ask what was there before? Time is a fundamental concept in physics, and is often defined as the progression of events from the past through the present and into the future. It is a fundamental dimension in which events occur, and is often represented as a continuous line or axis. In the context of physics, time is typically measured in units such as seconds, minutes, hours, and years. It is also an essential component of the space-time continuum, which is the four-dimensional fabric of the universe consisting of 3 spatial dimensions and 1 temporal dimension. The flow of time is often described as being unidirectional, meaning that it moves forward and cannot be reversed. This is known as the arrow of time and is often associated with the second law of thermodynamics, which states that entropy, the measure of disorder or randomness in a closed system, tends to increase over time. The nature of time is still a topic of ongoing research and debate in physics and philosophy. Some theories propose that time is an emergent property that arises from the complex interactions of the universe's fundamental components, while others suggest that time is a fundamental property of the universe, akin to space and matter particles violating the laws of nature in certain situations. 2 particles can seemingly have an instant connection with each other, even if they are located at opposite ends of the universe. The phenomenon is known as quantum entanglement, where 2 particles can become correlated in such a way that the state of one particle is instantly correlated with the state of the other, regardless of the distance between them. While this may seem like a violation of the laws of nature, it is consistent with the principles of quantum mechanics. However, it is important to note that this does not allow for faster than light communication or the violation of causality. This is because, while the state of the entangled particles may be instantaneously correlated, there is no way to control or manipulate this correlation to transmit information faster than the speed of light. There is a fundamental principle in quantum mechanics known as the no communication theorem, which states that it is impossible to use entanglement to transmit information faster than the speed of light. So while quantum entanglement may seem like a strange and mysterious phenomenon, it does not allow for the violation of the laws of nature or the principles of causality. Could this feature of quantum mechanics one day allow us to send information instantaneously over large distances? Are we alone in the universe? There are at least 2 trillion galaxies in the observable universe with more stars and planets in them than all the grains of sand on planet Earth. So where is everyone? Why haven't we encountered life from elsewhere? Is life incredibly rare, or does it have a limited lifetime, destroying itself before it has the chance to seek out other life forms? What does this tell us about the future of humankind? The question of whether or not we are alone in the universe is one of the most intriguing and profound questions we can ask. Given the vast size and age of the universe, it seems unlikely that Earth is the only planet with the conditions necessary for life to emerge. There are likely billions of potentially habitable planets in our galaxy alone. However, the fact that we have not yet encountered any definitive evidence of extraterrestrial life is known as the Fermi paradox. There are many potential explanations for the Fermi paradox, including the possibility that life is indeed rare, that it is difficult for life to evolve beyond a certain point, or that intelligent civilizations have a limited lifespan and self-destruct before they can explore the galaxy. It is also possible that we simply have not looked in the right places. Yet, our current methods of searching for extraterrestrial life are still relatively limited, and it is possible that more advanced techniques in the future could uncover evidence of life elsewhere in the universe. Does the self, Reference problem distort our perception of the universe. We humans are also part of the universe we inhabit. So when we look out to study the stars and galaxies, are we really neutral observers of the universe when we explore the universe? We are both observers and the subject of observation. How can we pretend to be neutral when we are deeply embedded in what we explore? Could it be that this self-reference problem affects the way we look at the universe and gives us an overwhelmingly wrong impression? The self-reference problem is indeed a complex issue when it comes to our study and perception of the universe. We are not neutral observers of the universe, but rather embedded within it. This self-reference problem can lead to potential distortions in our perception of the universe, as we may unwittingly project our preconceptions and assumptions onto our observations. For example, we may tend to focus on phenomena that we find particularly interesting or relevant to our existence, rather than taking a more objective and comprehensive approach. By acknowledging our own biases and limitations, we can work to develop more rigorous and objective methods of observation and analysis. Why is the universe seemingly so perfect for us? The universe seems to be perfectly made for us. But why is this? Why do the fundamental constants of our universe, such as the speed of light, have the values that they do allow life to exist? Could it be that there are infinite universes with infinite possibilities, and we merely happen to live in one that is perfect for life? There are a few possible explanations for this apparent fine-tuning of the universe. One possibility is the anthropic principle, which states that the universe is the way it is because it must be compatible with the existence of observer. In other words, the universe appears to fine-tune for us, because if it were not, we would not be here to observe it. This is sometimes referred to as the selection effect. Why is it easier to destroy something than to put it back together? Entropy is the amount of disorder, chaos, or randomness in a system. One can never reduce entropy. Everything in the universe slowly moves towards disorder. It's very easy to smash a window, but impossible to put it back together exactly as it was before the principle of entropy moved the universe from structure to chaos, from an ordered state to disorder. What does this tell us about the fate of the universe? As the universe continues to expand, it will eventually reach a state of maximum entropy where all matter is uniformly distributed and there is no energy gradient available to drive further processes. This state is known as the heat death of the universe, where the universe will be cold, dark, and lifeless. The universe is not a closed system as it receives energy from stars and other sources, but the overall trend is towards increasing disorder and chaos. However, it is important to note that this process will occur over an extremely long time scale. Likely trillions of years in the future, can anything escape a black hole? We have observed the effects of black holes, and we have seen one directly. The gravitational force of these massive objects pulls everything towards them, even light itself. What happens in the mysterious infinitely dense center of a black hole? Could there exist such things as white holes? The opposites of black holes that spew matter and time into our universe. According to our current understanding of physics, nothing can escape a black hole once it is past the event horizon, which is the point of no return. The gravitational pull of a black hole is so strong that it warps space and time, and anything that crosses the event horizon is inevitably pulled towards the singularity at the center of the black hole. Where the laws of physics, as we know them, break down, we do not know what happens at the center of a black hole. As our current understanding of physics is unable to describe the conditions, there it is commonly believed that the matter at the singularity is infinitely dense and compressed to a point of zero volume, known as a singularity. As for the possibility of white holes, which are hypothetical objects that are the opposite of black holes, there is currently no direct evidence to suggest that they exist. White holes are hypothetical objects that are believed to exist at the other end of a hypothetical wormhole, which is a hypothetical tunnel-like connection between 2 points in space-time. However, there is no direct evidence to suggest that wormholes exist either. The universe is full of strange and surreal paradoxes. our quest for understanding these is only just beginning. As we continue to push the boundaries of our knowledge and explore the furthest reaches of space and time, we can be sure that the universe will continue to surprise and challenge us in new and unexpected ways, spurring us into new and unexpected ways, and spurring us onto new heights of discovery and understanding. Nothing existed at the outset. After that, the cosmos began to take shape some 13.7 billion years ago. How this came to be, or if there was ever a time before time, is still a mystery. Yet physicists have pieced together an approximate timeline of significant events in the cosmos's existence using telescope data and models of particle physics from its beginning to its inevitable demise. We examine key points in the evolution of our universe here. Welcome to the endless universe. If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. The Big Bang. The Big Bang is a moment in time, not a location in space from when all else unfolded. To be more precise, it's the first second, the point in history from which all other seconds have been measured. The Big Bang, despite its common name, was not an explosion, but rather a time when the universe was incredibly hot and dense before space began to expand outward in all directions simultaneously. The Big Bang scenario suggests that the universe was an infinitesimally small point of infinite density. However, this is merely a convenient way of expressing that we don't know for sure what happened at that time. We now understand the cosmos breaking down at the Big Bang, because mathematical infinities don't make sense. In physics equations, in the cosmic inflation era, the next cosmic confab was to rapidly expand in size. The universe may have expanded exponentially after the Big Bang, tearing off previously colliding parts of space. This period, known as inflation, is still mostly theoretical, but it has gained favor among cosmologists as a possible explanation for the striking similarity between distant parts of space. Attempts to detect this expansion in light from the early cosmos were reported in 2014. But further investigation revealed that the true culprit was nothing more than interplanetary dust causing interference. Quark-gluon plasma. The temperature of the early cosmos was between 7 trillion and 10 trillion degrees Fahrenheit, or 4 trillion and 6 trillion degrees Celsius. Just a few milliseconds after the Big Bang, quarks, elementary particles ordinarily contained within protons and neutrons, were free to move about at these temperatures. These quarks were combined with gluons, carriers of the basic force known as the strong force, in a primordial that pervaded the whole universe. In particle accelerators on Earth, scientists have replicated these circumstances in both terrestrial atom smashers and the early cosmos. The challenging to achieve condition only lasted for a few fractions of a second. In the early epoch, the subsequent period, perhaps in the neighborhood of a few thousand seconds following the Big Bang, was a period of intense activity. The universe chilled as it expanded, creating an environment conducive to the merger of quarks into protons and neutrons. The cosmic neutrino background, which has not yet been detected by scientists, was created 1 second after the Big Bang, when the density of the cosmos decreased sufficiently for neutrinos to sail across space without interacting with anything. The first atoms, protons, and neutrons fused during the first 3 minutes of the universe's existence, creating the isotope of hydrogen known as deuterium, along with helium, and a trace quantity of the next lightest element, lithium. Yet this procedure ceased as the temperature dropped as the temperature settled down 380,000 years after the Big Bang. In the cosmic microwave background, a remnant of this epoch, first identified in 1965, was created when photons that had previously collided with electrons were able to flow without being disrupted. The Dark Ages. There was a lengthy period when nothing in the cosmos emitted any light. The cosmic Dark Ages refer to this time frame of around 100 million years, because practically all of what astronomers know about the cosmos can be gleaned by studying starlight. This era remains exceptionally challenging to study. It's hard to piece together what would happen if there were no stars to guide us. The first stars. The first stars were formed when hydrogen and helium began to compress into massive spheres. Some 180 million years after the Big Bang, creating hellish temperatures at their centers, after the neutral hydrogen atoms in interstellar space were broken apart into protons and electrons by the intense photons generated by early stars and galaxies. The cosmos entered a period known as cosmic dawn or reionization. It's hard to put a time limit on reionization as it happened. So soon after the Big Bang, its signals have been masked by subsequent gas and dust. Thus, the most that scientists can determine is that it was finished by around 500 million years after the Great Bang large-scale structure, almost a billion years after the Big Bang supermassive black holes developed at the cores of merging early galaxies. Intense quasars, visible from 12 billion light-years away, switched on and began emitting their bright beams of light. The universe's middle years, throughout the subsequent few billion years, the cosmos underwent more evolution. Denser regions in the early cosmos drew more material due to gravity. A gorgeous filamentary cosmic web is the result of them slowly expanding into galaxy clusters and lengthy strands of gas and dust that birthed the solar system. A yellow star with rings around it formed from a cloud of gas around 4.5 billion years ago in one galaxy. These accreted rings eventually became the 8 planets of our solar system, as well as numerous comets, asteroids, dwarf planets, and moons. Either the third planet out from the Sun retained a lot of water via this process, or it received a deluge of ice and water from comets later on Earth and humanity. Little primitive bacteria appeared in that third watery world between 3.8 and 3.5 billion years ago. These organisms arose and progressed into amazing marine monsters and enormous dinosaurs that fed on leaves. Some 200,000 years ago, upright beings emerged capable of contemplating the vastness of space and learning about the universe's origins. The end or not, it isn't the final chapter. Of course, the future of the cosmos is still a mystery to physicists. It is dependent on our ability to accurately quantify the characteristics of dark energy, the unknown factor thought to be accelerating the expansion of the universe. All the stars in all the galaxies will have burned out, and even black holes will evaporate into nothing if the universe continues to expand forever, leaving behind a lifeless cosmos saturated with inert energy if this scenario comes to pass. Alternately, the Great Crunch, a reversal of the Big Bang in which gravity triumphs over dark energy's expansionary force, will occur. The Great Rip, in which the cosmos rips itself apart, is another possibility. If dark energy accelerates everything apart to greater and greater distances. Thanks for watching, and don't forget to hit the like button, subscribe, and turn on notifications for more content like this. In the future, in its first few 100 million years, the cosmos looked very different. Gas and dark matter clouds were just starting to coalesce as gravity took hold. It was also around this time that the first stars composed entirely of hydrogen and helium began to develop astonishingly. However, by this time, some enormous black holes with masses of up to 1 billion stellar masses had developed in the standard model of black hole creation and growth. It would take billions of years for a black hole to expand to 1 billion solar masses, and the universe is less than 1 billion years old. Furthermore, if the present models of black holes are correct, then quasars and other extremely massive black holes should not have developed during that time period, but they were actually around in the primordial cosmos, when the cosmos was young. How did the largest black holes form? How did they put on so much weight in such a short amount of time, only a few million years after all is said and done? How does this new information affect our present knowledge of black hole birth? First, let me give you a quick overview of what a quasari is. It is a supermassive black hole that spins very quickly and consumes plasma at the core of a faraway galaxy, a phenomenon known as an active galactic nucleus. Quasars are extremely luminous and strong things in the cosmos. The brightness of some quasars can be billions of times that of our own Milky Way. The fascinating mystery, though, is what gives these things their incredible strength. The surroundings. Of course, quasars are typically found in galaxies with extremely high gas abundances. As the gas falls into the black hole in such a dense area, it heats up as it swirls around the event horizon. That's why it gives off radioactivity across the board in terms of frequency. Generally speaking, quasars are only discovered in extremely remote galaxies because local supermassive black holes do not have such large amounts of gas. Markarion 231 is one of the closest quasars, but it's still about 600 million light-years away. The question then becomes how such majestic revolving constructions come into being. There are currently two major hypotheses that can account for the overall creation of black holes. According to the first and most popular hypothesis, the death of a large star can result in the creation of a black hole with a mass of up to about 100 times that of the Sun. With enough time, this dark vortex can swallow its surroundings, causing the black hole to expand in size until it attains a supermassive state with a mass several million to several billion times that of the Sun. But experts agree that no black hole could ever devour enough matter in 500 million years to reach the mass of a billion suns. This is because as material falls into a black hole, it forms a circle called an accretion disk. As it orbits the black hole, the material in this ring achieves velocities close to those of light as a result of the g-forces. The disk heats up and emits a wide range of rays. This radiation exerts such a strong force that it drives away adjacent matter, slowing the black hole's rate of mass ingestion. Even if a black hole is capable of sucking in matter at a rate greater than the limit, the increased accumulation is still likely to result in strong gusts. The development will be halted as the nearby material is blown away by the strong gusts. The rate of black hole growth is capped by these variables. If this situation plays out, it would run counter to the idea that quasars formed in the normal manner in the early universe. Now we can discuss the alternative hypothesis for how quasars originate. According to it, black holes with masses up to 100,000 times that of the Sun formed when short-lived stars, some of which may have had lives of nearly 250,000 years, eventually imploded. Since this black hole was so enormous, it could have easily accreted billions of stellar masses in a short period of time. Furthermore, it is estimated that the initial mass of a quasar must be between 10,000 and 100,000 stellar masses, which lends credence to this hypothesis. However, the parent star must be exceedingly massive, nearly tens of thousands of times more massive than the Sun, for such a black hole to develop. However, such enormous stars have never been seen before. In the observable cosmos, even the heaviest star ever found is only about 300 times as big as the Sun. Additionally, there is no known process that can currently propel the creation of stars with masses many times that of the Sun. But we also know that circumstances in the early cosmos were different from what we see now. As a result, such stars could have developed in the early cosmos, as shown by simulations. Massive stars might have developed at the intersections of strong streams of dense and turbulent cold gas, but this would have been an extremely uncommon occurrence. However, for stars to develop, extremely bizarre circumstances would have had to exist, such as strong ultraviolet radiation or supersonic movements between gas and dark matter. To make matters worse, none of these out-of-the-way places have circumstances that are even remotely like those in which the first quasars were discovered. In that case, how do we account for the emergence of quasars? Scientists simulated the flow of the gas to get an idea of the solution to this query. A newborn star is typically formed when a compact mass within a cool cloud falls due to the cloud's gravity. However, such a fall cannot occur in the presence of substantial disturbance. Because of this, the model showed that the creation of typical stars, like the ones we see today, was inhibited by the turbulence produced by the stream's intersection. This instead caused the cloud in the simulation to expand so large that it disintegrated violently into two enormous stars, nearly 31,000 and 40,000 times the mass of the Sun. A supermassive black hole, billions of times the mass of the Sun, can develop and expand in just a few 100 million years, if the gas from the streams continues to fuel the clouds. This explains how even in the absence of unusual circumstances, supermassive black holes could have developed at the crossroads of gas streams. And if the numbers hold that about 200 quasars were born in the first billion years of the universe's existence, it's possible that we figured it out now. One of the study's authors, Daniel Whalen, quoted this way: "The first supermassive black holes were merely a natural result of structure formation in cold dark matter. Cosmologies are the offspring of the cosmic web." This is a stunning concept too. To ensure that you don't miss future episodes of this series, please like this video, subscribe to our channel, and click the bell symbol. Thanks for watching. I hope you enjoy it. Ladies and gentlemen, welcome to today's topic: aliens. Are they real? Do they exist? And if so, what do they look like? Today, we will dive deep into the topic of aliens, exploring various theories and facts about these mysterious creatures. If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. Here are a few theories about aliens. Extraterrestrial life exists. This is the theory that life exists elsewhere in the universe, perhaps even within our solar system. Microbial life could potentially exist on Mars or some of the moons of Jupiter and Saturn. For example, more complex life forms such as intelligent civilizations could also exist on planets orbiting other stars. The Fermi paradox suggests that if intelligent life is common in the universe, why haven't we detected any evidence of it? Some theories suggest that intelligent civilizations tend to self-destruct, while others propose that they are too far away or have no desire to communicate with us. Ancient aliens. This theory suggests that aliens have visited Earth in the past and have influenced human history and culture. Proponents of this theory point to ancient artwork and texts as evidence of alien visitation. UFO sightings of unidentified flying objects are often cited as evidence of alien visitation. While many sightings can be explained by natural phenomena or human-made objects, some remain unexplained and could potentially be evidence of extraterrestrial visitation. The simulation theory. This theory proposes that our entire reality is a computer simulation created by an advanced civilization, not specifically about aliens. This theory suggests that the creators of the simulation could potentially be an extraterrestrial civilization. To start with, let's address the most basic question. Do aliens exist? Well, according to the Drake equation, which was developed in 1961 by astronomer Frank Drake, the probability of intelligent life existing elsewhere in the universe is high. The equation takes into account factors such as the number of stars in our galaxy, the number of planets that could potentially support life, and the probability of life forming on those planets. The Drake equation estimates that there could be millions of intelligent civilizations in our galaxy alone. But the question remains, have we ever encountered these civilizations? Many people believe that we have, and there are countless stories of alien sightings, abductions, and encounters. However, there is little concrete evidence to support these claims. So let's explore some of the most popular theories about what aliens might look like. The traditional image of aliens as small green beings is a product of popular culture. However, it is unlikely that aliens would look anything like this. It is impossible to predict what aliens might look like, as their appearance would depend on the conditions of the planet they evolved on. For example, if an alien species evolved on a planet with high gravity, they might have shorter, stockier bodies. If they evolved on a planet with a harsh radiation-filled environment, they might have evolved to be more resilient to radiation. It's also possible that some alien species might not even have bodies. As we know them, they might exist as pure energy, or as a hive mind collective. But why would aliens visit Earth? There are a few possible reasons. Some scientists speculate that aliens might be interested in our planet because of its unique location in the universe. Earth is in a Goldilocks zone. It's not too hot, not too cold, and has the right condition for life to thrive. Aliens might be interested in studying our planet to learn more about how life can survive in these conditions. Another reason aliens might visit Earth is to make contact with us. If there are millions of intelligent civilizations in the galaxy, some of them may be trying to communicate with us. However, if this is the case, they might be communicating in ways that we can't even comprehend. Their methods of communication might be vastly different from ours. So what should we do if we ever do encounter aliens? Many scientists believe that we should approach any encounter with caution. We should avoid making any sudden movements or aggressive actions, as these might be misinterpreted by the aliens. Instead, we should attempt to communicate in a peaceful and non-threatening manner. If we do make contact with aliens, it could have profound implications for our understanding of the universe. It could challenge our beliefs about our place in the cosmos and force us to confront some of the big questions about life, the universe, and everything. Now that we've explored some of the theories and possibilities of alien life, let's consider the idea of the Fermi paradox. This paradox asks the question, if there are so many intelligent civilizations out there, why haven't we seen any evidence of them? Why haven't we detected any signals or observed any spacecraft from other worlds? One possibility is that advanced civilizations tend to self-destruct. With technology comes the potential for destruction, whether through environmental damage, war, or some other catastrophe. Many intelligent civilizations may reach a point where they are unable to sustain themselves and ultimately fail. Another possibility is that intelligent civilizations have no desire to make contact with us. Perhaps they are simply not interested in Earth or in communicating with other species, or perhaps they are too far away to detect our signals and we are too primitive to detect theirs, regardless of the reasons. The Fermi paradox remains a mystery and a subject of much speculation. But let's turn our attention to the possibility of life in our solar system. While we haven't found any evidence of intelligent life, there are some promising signs that microbial life might exist on other planets or moons. For example, NASA's Mars rover has detected methane on the planet's surface, which could be a sign of microbial life, and scientists have found evidence of subsurface oceans on some of Jupiter and Saturn's moons, which could potentially support life. If we do find evidence of microbial life in our solar system, it would be a major discovery and could have significant implications for our understanding of life in the universe. Let's consider the potential implications of discovering intelligent life. If we were to make contact with an alien civilization, it could have profound impacts on our society and our understanding of the universe. For one, it could challenge our existing beliefs and worldviews. We might need to re-evaluate our ideas about our place in the cosmos, our religious and philosophical beliefs, and our understanding of the origins of life. It could also raise questions about the ethics of interacting with other intelligent species and the responsibilities that come with such interactions. Another potential impact is on our technology and scientific progress. If we were to encounter a more advanced civilization, we could learn from their technology and knowledge, potentially accelerating our progress. On the other hand, it could also pose a threat if the aliens have hostile intentions towards us. It's difficult to say for certain whether aliens, if they exist, would be dangerous to us. We have no concrete evidence of intelligent extraterrestrial life, so any speculation about their intentions or behaviors is purely hypothetical. Some people argue that aliens could be dangerous if they are more technologically advanced than us and have the ability to conquer or destroy us. Others point out that any civilization advanced enough to travel through space would likely have a more sophisticated understanding of the universe and maybe be more peaceful and cooperative. It's also possible that aliens could be indifferent to us simply by observing us from a distance without any intention to interact with us at all overall. While it's fun to speculate about the potential dangers of alien life, the truth is that we simply don't know enough to make any definitive conclusions about their intentions or behaviors. The search for extraterrestrial life should be approached with an open mind and a healthy dose of curiosity, rather than fear or paranoia. Regardless of the potential impacts, the search for intelligent life continues. We are constantly developing new technology and refining our techniques to search for signals and evidence of other civilizations, and while the chances of finding intelligent life may be slim, The pursuit of knowledge and discovery is a worthy endeavor in and of itself. That's all for today's topic of aliens. We hope you've enjoyed this discussion and learned something new. If you have any questions or comments, please leave them in the comment section below. Thanks for tuning in, and we'll see you next time. Is it possible for science fiction to become reality? I believe the reason Hollywood is so interested in the prospect of first contact with aliens is simple. It would be the biggest scientific discovery in human history. The problem is that our cosmos erects enormous hurdles to encountering extraterrestrials. It's almost as if the cosmos is trying to keep us from establishing first contact on purpose. We're looking for answers in the universe. Will we ever discover intelligent extraterrestrial life? Or are we alone? Arecibo Observatory blasted a strong radio message deep into space 45 years ago, launching our efforts to make first contact. The Arecibo transmission was the first communication or effort to connect with a hypothetical civilization outside our galaxy. That communication is currently en route to the M13 galaxy cluster, which is about 25,000 light-years distant. It carries data about our planet, our location, and even the composition of our DNA. The goal of this communication was, of course, to say hello and also to raise the question, are we alone in the universe? But how likely is it that an intelligent alien culture is waiting for our message? Do you believe there is intelligent life in the universe? The answer is yes. Yes, we know that life originated on Earth almost as soon as our planet formed, so why wouldn't it have occurred someplace else? How many extraterrestrial civilizations may we possibly contact if life has developed on other worlds? Frank Drake. An astronomer devised an equation to assist in answering this critical topic. The Drake equation is a really remarkable effort to apply mathematical logic to the likelihood or potential of life beyond Earth. They also projected that there were about 10,000 intelligent civilizations in our galaxy since the Drake equation was initially developed. Our knowledge of the galaxy has changed dramatically. Exoplanets are worlds found beyond our solar system. Exoplanets are being found all over the place. There are about 4,000 of them now known, and techniques are finding more every day. Scientists think what we've discovered is only the top of the iceberg. So if the universe is so excellent at creating planets, maybe it can create the conditions for life to exist across the universe. We didn't know exoplanets existed when the Drake equation was developed decades ago. And today, scientists believe that there are more planets than stars in the cosmos. Even though life is very uncommon, there are many opportunities for it to emerge throughout the cosmos. As a result, it is quite possible that there is reasonably plentiful life in the cosmos, including an uncountable number of sophisticated extraterrestrial civilizations. This isn't science fiction, it's just basic probability. Most likely, there are many different alien cultures out there, so don't you think it's a little strange that we haven't met yet? I think there are good reasons to think there are civilizations out there. Why haven't we found any other societies? One answer could be the sheer vastness of the cosmos. We live in the suburbs of the Milky Way. 75,000 light-years from the very edge, radio signals travel at the speed of light. With this speed limit, a signal sent to the other side of the galaxy would take 75,000 years to get there. The thing to keep in mind is that the galaxy is very big. Even if there are 10,000 civilizations in the galaxy, the distances between the stars may be so great that we'll never be able to talk to each other. So imagine we sent a message into space 45 years ago, hoping to reach any potential aliens out there. Well, guess what? That message is still super far away from its destination because it's cruising at the speed of light. The place we're trying to reach is a whopping 25,000 light-years away. The vast size of the universe is a huge roadblock to making first contact. And that's a bit of a problem when it comes to reaching out to potential extraterrestrial buddies. The laws of physics are like a roadblock, preventing radio signals from zooming across such vast distances. It turns out you can't break the speed limit of light, so even though there might be cool civilizations and life forms out there in our galaxy, they're just so darn far away. I hate to be the one to say it, but the universe is just too darn large. Fear not, we're not giving up. In fact, we're using the best technology on Earth to speed up the search. The Breakthrough Listen project is our superhero in this quest. Imagine high-tech facilities. Worldwide radio telescopes and optical telescopes are all teaming up to scan the sky. They're focusing on the 1 million stars and 100 galaxies closest to us, making it the most epic search for alien chatter ever. So if there's an alien aircraft around any of the 1,000 nearest stars, the Breakthrough Listen project is on it like a detective on a case. They've got the tools to catch any signals and make sure we don't miss out on an intergalactic conversation. Breakthrough. Listen is like a cosmic detective trying to catch any signals from outer space right now. They're eavesdropping on the closest 17 stars to us, hoping to hear something exciting. But guess what? It's been pretty quiet so far. It's kind of like waiting for a phone call that never comes. It's frustrating because we haven't found any proof of alien civilizations yet. But here's the catch: just because we haven't heard anything doesn't mean they're not out there. Breakthrough. Listen is just getting started on its mission, and there's a whole lot more space in the universe to explore. Imagine it like searching for a needle in a cosmic haystack. It takes a ton of patience. Now, let's do some space math. If you use Drake's equation and figure, there could be 10,000 intelligent civilizations. Consider this: there are around 250 billion stars in our galaxy. That's like looking for one specific house in a city of 25 million houses. It's a massive task, a bit like making a Brazilian cold calls. The universe is so vast that we might have to wait a long time before picking up any alien signals, and even if we do hear something, it might be too late. Imagine getting a message from someone, but they sent it ages ago, and by the time it reaches us, it could be history. So are we just fashionably late to the cosmic party? Could some aliens have come and gone already? Earth may have been around for a whopping 4.5 billion years, allowing us to evolve into a smart species, but in the grand scheme of the universe, we're just cosmic toddlers. The Earth is super old, like over 4.5 billion years old, and guess what? It took all this time for us humans to become the cool tech-savvy civilization we are today. But here's the kicker. There are star systems out there that have been around even longer than us. The universe itself is a whopping 13.8 billion years old. Wrap your head around the fact that we often think we're top-notch because we can build rockets and play with radio waves. However, if we met a civilization that's been around way longer than us, they'd probably be light years ahead in technology. There's this cool way of measuring how advanced civilizations might be. It's called the Kardashev scale. It sorts civilizations into 3 types based on how much energy they can grab from their surroundings. Type 1 can only use the energy of its home planet. Type 2 could potentially harness the energy of its entire solar system. And Type 3, well, they're the big shots that could harness the power of a whole galaxy. And here's the buzzkill. We're not even a Type 1 civilization, we're somewhere between 0 and 1 on the scale. We can't fully tap into all of Earth's resources, so we're sitting at a modest 0.7, but hey, we're trying our best to catch up with our cosmic neighbors. Imagine an advanced civilization hitting Kardash with level 2 or 3. These guys could create mind-blowing structures that tap into the power of a star, massive solar panels enveloping the entire star, a concept first dreamed up by Freeman Dyson. These cool structures are called Dyson spheres. If other star systems or even entire galaxies have these epic Dyson spheres, could we catch a glimpse and finally make contact with these advanced beings? Here's the deal with Dyson spheres. They block almost all the light from a star, except for this sneaky infrared light. Why? Because those panels are soaking up sunlight and getting warm, and when things warm up, they give off thermal infrared light, so we can play cosmic detectives by scanning the skies for this tail, thermal infrared signature, to spot Dyson spheres. Back in 2015, NASA's Wide Field Infrared Survey Explorer scanned 100,000 nearby galaxies on the hunt for these advanced civilizations. They detected nothing, but here's the cosmic conundrum. The universe is crazy old, right? So shouldn't other civilizations have had plenty of time to evolve? Well, maybe we just haven't noticed them yet. Imagine this. They're out there trying to send us a message, but it's like they're knocking on our door before our house is even built. Earth has been around for less than a third of the universe's 13.8 billion years, and humans have been strutting our stuff for just 300,000 years. That's a tiny window in the grand scheme of the cosmos to make that first contact. It's like trying to join a party, but you're fashionably late, and the party's been going on for ages. The hypothesis of natural filters in the universe posits that advanced extraterrestrial civilizations may have existed for a long time, but were eradicated by these natural filters. If extraterrestrial life exists, the question arises as to whether their forms and environments would be similar to those on Earth. This idea draws from the concept that certain conditions, whether astrophysical, biological, or societal, act as filters that limit the emergence and longevity of advanced civilizations. Possible filters include cataclysmic events, astrophysical phenomena, or self-destructive behaviors inherent to intelligent societies. If extraterrestrial life exists, its forms and environments might not necessarily resemble those on Earth. Life could evolve in diverse ways, depending on the unique conditions of each planet. The variety of planetary environments and the adaptability of life make it plausible that extraterrestrial beings might have different biochemistries and physical characteristics. Rocky planets like Earth are considered ideal for supporting life due to their specific conditions. However, these planets are delicate and susceptible to various threats, and this fragility means the universe could filter out intelligent life quickly. One significant threat comes from violent stellar events, such as gamma-ray bursts, which are powerful enough to sterilize planets over vast cosmic distances, potentially affecting entire galaxies. Imagine this: a huge star explodes in our galaxy, the Milky Way, sending a deadly burst of energy hurtling toward our planet. This is a gamma-ray burst, which is the biggest blast since the Big Bang. There are no signs that something bad is about to happen, and then it strikes. The radiation that is pumped up heats up the high atmosphere. Our layer of ozone heats up across the atmosphere. Human beings burns to death from radiation, 100 times the fatal dose. When the ozone layer gets thinner, temperatures rise all over the world. This makes storms, tsunamis, and hurricanes happen. Most life on the surfaces of land and water incinerates. This may sound like science fiction, but if a gamma-ray burst from 100 light-years away hit Earth, it could happen even if intelligent species manage to survive these natural occurrences. There is another risk: self-destruction, drawing from our own experiences on Earth. The development of technology has given us the capability to alter our climate and create weapons of mass destruction. This self-destructive potential poses a serious risk for advanced civilizations. It is plausible that technologically advanced societies may have a brief existence, as evidenced by our history. The short lifespan of advanced civilizations could be a reason why there are so few observable ones at this point. The possibility arises that many civilizations may have emerged, but their existence was short-lived due to self-inflicted challenges. This scarcity of long-lasting civilizations could explain the limited opportunities for communication with extraterrestrial beings. Discovering the remnants of an extinct alien civilization could serve as a profound warning for humanity. If we were to find evidence of a civilization that destroyed itself through pollution or conflict, it would be akin to looking at our own potential future. This sobering realization could provide valuable lessons for us on Earth, emphasizing the importance of avoiding similar pitfalls in our quest for understanding the cosmos. We can only hope that some advanced alien species have managed to navigate the challenges posed by the universe's potentially lethal filters, offering a glimpse of long-term survival and prosperity. If we are lucky, there may be an extraterrestrial civilization that will come to visit us in the future. Imagine making contact with aliens. Sounds cool, right? But hold on, are we assuming too much? We tend to think that aliens are just like us, but here's the twist: they're not. We might be imagining them based on what we know about life on Earth, assuming they live on planets like ours. But guess what? Most of the universe might not follow our life and planet rulebook. So could extraterrestrials even survive first contact with us and our planet? In July 2019, a satellite on a test mission spotted a new alien world named GJ357d about 31 light-years away. This super-Earth is over 6 times heavier than our cozy home planet. Now, what's super-Earth? A terrestrial planet, but bulked up with more mass. More mass means more gravity, creating a whole different vibe compared to our Earth. Imagine aliens living on a super-Earth. The gravity there could be super strong. They might not be tall, but I bet they'd be super strong. Super-Earths are just one of the many wild things the universe cooks up. Who knows what other surprises are out there? The possibilities are as vast as the cosmos itself. The universe is a vast playground with planets of all shapes and sizes, orbiting stars of various types and sizes, forming countless configurations. This diversity opens up a world of possibilities for life that is much richer and more varied than we ever imagined. However, we need to break free from the idea that extraterrestrial life will resemble us. If we're expecting beings with 2 legs like ours, we might as well abandon that notion. The truth is, life out there could be radically different. Consider this scenario. An intelligent alien species in our cosmic neighborhood wants to say hi to us. But here's the catch. If that alien evolved on a super-Earth, or circled a red star instead of a yellow one, its biology could be so alien that it might never set foot or tentacle on our planet. Looking at life on Earth, it seems like it's tailor-made for our specific temperature, elements, and environment. Now imagine an exoplanet with conditions conducive to life. It could still host life forms vastly different from what we're accustomed to. What if an alien world has a bit more potassium, is warmer than our average Earth, or has a thicker atmosphere? Each of these subtle differences could create an entirely distinct ecosystem. So the big question is, can an alien organism truly adapt to our ecosystem? When it lands on Earth, it's a cosmic mystery waiting to unfold. The Earth is shaped by its oceans, which play a vital role in supporting life. Without these oceans, life as we know it would not exist. While we used to believe that Earth's oceans were unique, recent discoveries have shown that oceans are not exclusive to our planet. Surprisingly, similar oceans have been found in various locations within our solar system. Scientists are embarking on an extraordinary quest to explore unlikely places in the hopes of discovering new forms of life. It's fascinating how life continually surprises us with its remarkable ability to exist in unexpected places. Water is incredibly important, and it has guided scientists in their search for life in our solar system all living things require. Water is a common factor for all forms of life on Earth. Oceans, being suitable environments, provide the necessary conditions for life to develop and survive. Wherever we find water on Earth, whether it's cold or scorching hot, we also find life. Considering this, scientists established a simple criterion for the search for extraterrestrial life: find a liquid ocean. However, within our solar system, it initially seemed that there were no such oceans beyond Earth. The concept of the Goldilocks zone suggested that a planet needed to be at just the right distance from the Sun for water to exist in a liquid state on its surface. Earth was perfectly situated, while Venus was too hot due to its proximity to the Sun, and Mars was considered too far away. Exploring the possibility of water on Mars has been a captivating endeavor for scientists and space enthusiasts alike. The Red Planet, with its barren and desolate surface, has long been a focal point of planetary exploration. In recent years, the quest to find signs of liquid water or evidence of its historical presence has gained momentum. This pursuit is not merely a scientific curiosity. It holds the key to unraveling the mysteries of Mars' past and present, and perhaps uncovering the potential for extraterrestrial life. Despite our extensive knowledge about Mars gathered over decades of exploration, the evidence so far suggests that Mars is dry, cold, and seemingly devoid of life. However, the question arises, has Mars always been this way? Interestingly, scientists are searching for evidence of an ancient Martian ocean in one of the driest places on Earth, the Atacama Desert in Chile. The connection between Mars and Atacama lies in their extreme dryness. Mars is known for being very dry, and Atacama is among the driest places on Earth. The relative humidity measured by the Curiosity rover on Mars is nearly the same as what we experience here in this desert. Surprisingly, the lack of water in Atacama made it an ideal location to build one of the world's largest telescopes. Water in the atmosphere could significantly hinder the telescope's ability to detect water and other substances. Scientists are specifically searching for water and organic materials, so they choose places devoid of these elements, like deserts, to avoid contamination. When observing the atmosphere, when observing Mars through a telescope, it becomes evident that there is water on the planet currently frozen solid at the poles. However, the Martian landscape suggests past shaping by liquid water, raising questions about the amount of water that once existed on the planet. The mystery started to unravel in 1984 when scientists made a fortunate discovery in another desert, the coldest place on Earth, Antarctica. They found a remarkable meteorite of Martian origin, and its analysis provided the key to understanding Mars' watery history. Through meticulous analysis, scientists determined that the meteorite was an astounding 4.5 billion years old. This meteorite held crucial chemical information, a fixed isotopic signature reflecting the amount of water present on Mars 4.5 billion years ago. Although the signature alone may seem insignificant, its value became apparent when scientists measured the current water content on Mars by comparing the isotopic signatures of recent rocks with those of the ancient meteorite. A wealth of information was unveiled. The significance of the enormous telescope comes into play. Here, its remarkable power allows it to detect water molecules on the planet's surface. Armed with precise measurements of Mars is present. Water content, scientists could make a remarkable calculation. They extrapolated back in time and concluded that there was nearly 7 times more water on Mars in the past than there is today. To understand this transformation, scientists looked at Mars' topography. The planet has low plains in the north and high-altitude plains in the south. In terms of topography, if water were to flow, it would naturally move towards the lower northern plains. A captivating journey into Mars's ancient past reveals a remarkable story. Approximately 4.5 billion years ago, Mars boasted a vast ocean covering 19% of its surface, rivaling the depth of the Mediterranean Sea. Ross's planetary models depict Mars in its prime, featuring a warm climate and an Earth-like atmosphere. Imagine arriving in an alien spacecraft on Earth. Chances are high that you'd land in the water. Early Mars shared this water-centric characteristic, earning it the title of a water world. It was a world potentially teeming with life, even hosting waves twice as tall as Earth due to Mars. Lower gravity. A surfer's dream, early Mars, with its water and thicker atmosphere, resembled the Arctic Ocean, choked and frigid, although farther from the Sun than Earth. 4.5 billion years ago marked Mars's most habitable era, akin to our planet during its formative stages. Interestingly, this was the time when life emerged on Earth despite its promising conditions. Mars's early ocean faced a tragic fate over 1.5 billion years. The Martian atmosphere succumbed to solar radiation, evaporating away, leaving only 13 frozen at the poles. The tantalizing question arises, could life have existed in that ancient Martian ocean? And if so, could anything have survived to the present day? The key lies in the possibility of finding liquid water on Mars. The Curiosity rover exploring Mars since 2012 has been a crucial part of this quest. Staggering images like the mesmerizing blue sunset challenge our perceptions of the red planet. The Mars Reconnaissance Orbiter's pictures of the Newton crater provide further insights into the remaining liquid water on Mars. Time-lapse sequences reveal streaks on the crater walls, possibly indicating the presence of water, albeit in smaller amounts compared to Earth's oceans or Mars's ancient water world. The pursuit of liquid water on Mars continues to open the door to the tantalizing possibility of discovering life beyond our home planet. Mars's unique conditions are influenced by its axial tilt, while Earth's axis is stabilized by the Moon acting as a gravitational outrigger. Mars lacks a large moon and is closer to Jupiter. As a result, Mars experiences a significant wobble in its axis, more than double that of Earth over 100,000 years. Mars tilts and wobbles by as much as 10 degrees, causing dramatic climate changes similar to, but more extreme than Earth's ice ages. The harsh conditions, coupled with the absence of a stabilizing factor like the Earth and Moon, pose substantial challenges to the potential survival of life on the Martian surface. Our solar system is a harsh environment, and volcanoes are destructive everywhere, from the ice volcanoes of Saturn's moon, Enceladus, to the immense lava fields of Jupiter's moon. To our own planet Earth, volcanoes' influence and alteration of our climate are both the creators and destroyers of existence. Today's spacecraft and observatories have revealed volcanoes on planets we once believed to be dead. The discovery of volcanoes on an object smaller than the moon was a major surprise. If there are volcanoes on other worlds, could there also be life? Volcanoes are among the most potent natural occurrences on Earth. They create new land, destroy the old, and emit gases that alter the atmosphere we breathe deep in our oceans. Volcanic heat fuels bizarre new forms of life. Volcanoes help sustain life on Earth. Now that we look for signs of life on other planets, we understand that life requires water. We are aware that it requires energy, and this is where volcanoes come in, as they generate tremendous quantities of energy. If we locate volcanoes on other planets, we may discover life. The search begins with this planet, which orbits the Earth closest to Venus, a planet that closely resembles our own Venus. Venus and Earth have similar masses. Earth and Venus were very similar. 3 billion years ago, with new land, new oceans, and an atmosphere, both planets were conducive to life on Venus. However, something went awry. Something caused the history of Venus to diverge drastically from that of Earth. Venus took a definite turn to the dark side. A long time ago, Venus was hell, our malevolent twin planet. Today, the surface of Venus is like a furnace. The surface is 900 degrees Fahrenheit hot. It is heated enough to melt some metals, so you have no chance. Venus is a greenhouse world. Its atmosphere contains a high concentration of carbon dioxide. It absorbs solar heat like a blanket. Actual images of Venus's surface reveal a desolate, extremely hot desolation. The planet was annihilated by the CO2 atmosphere. The CO2 was produced by volcanoes. Spacecraft in orbit provided the initial clues. Radar broke through Venus's thick clouds and showed volcanic formations all over the planet. These formations look a lot like the shield volcanoes on Earth. Round and flat shield volcanoes derive their name from their shape. These volcanoes ooze, but they ooze for thousands of years. Once we were able to map the entire surface of Venus using cloud-penetrating radar, we began to examine its landforms and discovered that many of them were quite familiar. In particular, we observed enormous shield volcanoes that resembled the shield volcanoes in Hawaii. The radar images of Venus were identical to those of Hawaii's shield volcanoes. In the past, Venus was home to volcanoes. We were astounded to see a picture of Venus. For the first time, we discovered a cratered volcanic surface. There are at least 1,000 large volcanoes, and possibly tens or hundreds of thousands of lesser ones. Lava plains cover 3/4 of Venus's surface, evidence of an ancient catastrophe. This could have been a home for life, but it was instead consumed by flames. Numerous trillions of tons of carbon dioxide were expelled by Venus's volcanoes into the planet's atmosphere. The temperature rose dramatically, the oceans evaporated, and carbon dioxide was able to absorb into the rocks. It can be absorbed by the ocean on Venus, but there is no water. And the temperature is so high that carbon dioxide cannot even combine with the minerals. Volcanoes released carbon dioxide into the atmosphere eons ago, and as time passed, fewer and fewer methods existed to remove it from the atmosphere. Volcanoes sanitized the entire planet. If Venus ever supported life, Earth is the only known planet with life that may alter this. The gas giant Jupiter, with its moons, is believed to be frozen and lifeless. A mystery surfaces as a cloud hovering over a cold and lifeless world. Upon closer inspection, Venus's volcanoes transform the planet similar to Earth into a hyperheated inferno. Volcanoes on a planet similar to Earth were not a surprise, but the discovery of volcanoes on the Moon was an astonishment in March 1979. The Voyager 1 spacecraft provided us with our first up-close look at Jupiter's minuscule moon Io, a world we once believed to be frozen and lifeless. And they witnessed something odd. They observed this arc next to the moon, and it almost appeared as though there was a second moon behind it. We scratched our minds and asked, what could that be? Everyone is aware that Io is lifeless, dull, and uninteresting. And then people realized, oh my god, it's a volcanic eruption. We discovered that the area is engulfed in volcanoes. It is geologically extremely active. There are constant volcanic eruptions. And what they're erupting is a great deal of sulfur, which becomes extremely heated. And sulfur changes color as its temperature changes. It may be red, orange, yellow, or even black. As a result, these images of Io's visage resemble a pizza with various types of cheese and olives, where the small black spots are. Io is not dead, it is alive. And growing, there are more than 400 active volcanoes. The largest Pele erupts from a gigantic lava lake. It extends approximately 400 kilometers into space. It would be an extraordinary sight if we could stand on the edge of that lava lake and observe that plume shooting off into the void of space. Pele's eruptions are so massive due to Io's diminutive size, there is nothing holding the lava back, as there is virtually no atmosphere and little gravity. These enormous eruptions make Earth's volcanoes resemble fireworks. How can a moon so small be so volcanic? The answer is Jupiter. Similar to how the moon raises the tides in the Earth's oceans, Jupiter raises solid rock tides on Io. The orbit of Io around Jupiter is not circular. Sometimes it's closer, sometimes farther away. Jupiter exerts a gravitational force. On Io, Jupiter's gravity stretches and squeezes. In every 2-day orbit, the ground rises and falls by nearly 300 feet. This pummeling generates extreme heat and enormous pressure wherever there are weak spots in the crust where lava erupts. Volcanism is therefore planet scale, in contrast to Earth, where certain portions are active around the plates or in weak areas. This is an entire moon that's one active hotspot. It is the most volcanism active planet in the solar system. As a result of the immense power of gravity, volcanic activity on Io has taught us something new. It taught us that internal energy sources can drive volcanism in a manner distinct from that on Earth. It is a lava world that is extremely hot and violent. It is difficult to conceive of anything surviving there. We have discovered strange eruptions on numerous planets and moons, but so far, the only world where volcanoes are linked to life is ours, or so we thought. It orbits Jupiter at a distance of nearly 500 million miles from the Sun and is a 2,000 mile wide sphere of ice. From afar, its surface appears to be polished up close, but it's a different story. Europa is pummeled by Jupiter's immense gravity, just like its companion Io. The surface rises and bends, forming ridges and deep fissures. When we first obtained close-up images of Jupiter's moon Europa, they seemed vaguely familiar. And it turns out that they resemble Arctic ice flows. And it turns out they are the same. A global liquid ocean lies beneath Europa's several-mile-thick icy crust. Magnetic measurements indicate Europa's ocean is an astounding 60 miles deep. The gravitational impact of Jupiter heating the rocky interior and melting the ice above as the core is stretched by tides and heated, possibly melting, is not preposterous to believe that there is a boundary between a hot core and a liquid water ocean. Underwater eruptions on Earth are surrounded by life. The same may occur on Europa. Here, the darkness is complete. The pressure is a crushing 2,000 Earth atmospheres, a harsh environment, but perhaps a cradle for life if there is evidence of life on Earth. Why not make Europe an energy source? Volcanic activity, a universal solvent, liquid water, and complex hydrocarbon chemistry are all present. Life would be difficult but not impossible on Europa. There is life at every extreme on Earth, including searing heat, crushing pressure, and absolute darkness. Life on Europa may resemble our own in unanticipated ways. If life exists beneath Europa's ice, it would be aquatic, but without eyes, because there are no significant light organisms that essentially feed off the energy of the volcano. They would most likely utilize sonar to make sense of their surroundings. Volcanoes on Europa could be the genesis of new life. It is even conceivable that Europa is typical. This is the norm for planets with life. Earth may represent an exception. Consider that Europa could serve as a model for the billions of moons in the universe, with liquid oceans, so all of a sudden our horizons have expanded several billion times by looking at the moons of Jupiter. Our solar system is home to more than 170 moons. Multiply this by the size of the universe, and that's a lot of potential habitats for life. Only liquid water and a source of energy are required. Potentially, both are provided by volcanoes, and they are ubiquitous. This is Saturn, twice as far from the Sun as Jupiter. However, it also has volcanic moons, and similar to Europa, these moons could support life. Saturn is one of the odd planets in our solar system with a 600,000 mile wide ring system, an astounding 62 moons, and one with a secret. Enceladus is one of the lesser and more distant moons of Saturn, and it's been known for a long time that it's covered in ice due to its extremely brilliant and reflective surface. However, when the Cassini spacecraft visited the planet, it made a remarkable discovery. Not on the planet itself, but on Enceladus. A massive plume backlit by the sun and erupting into space is conclusive evidence of volcanic activity. Cassini sensors zoom in on the south pole of the moon to capture these enormous craters scarring at surface at the south pole of Enceladus. There are extraordinarily large fissures which open and close. As Enceladus orbits Saturn due to the tides, now these fissures are enormous. They extend for hundreds of kilometers, and when they begin to open, you would see a large crevasse opening at approximately 100 miles per hour. Along its length, it'd be incredibly spectacular. Huge gravitational forces cause the surface to open and contract with incredible velocity. This helps produce the heat necessary to dissolve ice and form oceans beneath the surface. The conditions of the water beneath the surface of Enceladus are ideal for life. It is at the ideal temperature. It would be beneficial for life. Liquid water would be just like seawater here on Earth, and the chemistry of the water we observe erupting from these fissures suggests that it contains salt. It contains organic matter as well. Therefore, we have identified a location in the solar system where there is a strong possibility that there is life right now. In the ice particles, Cassini has detected complex carbon molecules in conjunction with liquid water. They suggest that perhaps life could exist deep within this mysterious moon. Enceladus is possibly not alone. Another of Saturn's moons might also harbor life. Titan, one of the largest moons in our solar system, the only moon with a thick atmosphere, a frozen world, ice as hard as rock lakes of liquid methane. Yet, we may also discover evidence of volcanoes and the tantalizing possibility of extraterrestrial life on this planet. Volcanoes are one of the most destructive forces in the universe, as evidenced by Io's raging configuration and Triton's ice and nitrogen explosions, even on Saturn's enigmatic moon. Titan, however, destruction can lead to the prospect of life. It has a diameter of 3,000 miles, making it larger than Mercury. It has the thickest atmosphere of any moon in our solar system. There is weather, including cyclones, winds, rain, and even lakes, but the temperature is so low that liquid methane replaces water, and it's loaded with essential compounds for life. Titan has proven to be one of the most fascinating locations in the solar system. It's an active world. It is the only moon with a dense atmosphere. An atmosphere very similar to that of Earth due to the presence of nitrogen. As it turns out, organic molecules high in Titan's atmosphere react with sunlight to produce compounds essential to life. But if sunlight consistently converts methane into organic compounds, why does methane not run out? Methane is abundant in the atmosphere, but we know that it is quickly eliminated by sunlight, so it shouldn't be there. There must exist a source of methane. Something on Titan emits methane in a continuous stream. Cassini has spotted what appears to be a crater. Infrared cameras disclose that the crater is surrounded by various types of materials. Scientists believe the green areas may be volcanic, possibly plains of lava ejected from Titan's interior. On Titan, the boiling liquid emitted by volcanoes could be either ammonia or water. Methane and ethane are emitted by Titan's volcanoes, and this is likely the cause of the planet's extremely dense cloud cover and orange atmosphere. This atmosphere likely originated from the outgassing of Titan's volcanoes. Even on a globe as frigid as Titan, volcanoes require heat on Titan. There are two sources of heat: radioactive substances that heat the interior, and Saturn's enormous gravity caressing the moon, similar to Enceladus. These two forces produce sufficient heat to transform ice into water and liquid methane into gas. Could volcanoes on Titan give life a chance to survive? Volcanoes could provide everything on Titan. If life does exist on Titan, it would be truly alien. It would breathe hydrogen instead of oxygen and possibly swim through methane reservoirs at 300 degrees below zero. There may be oceans of ethane. Possibly there are tidal pools, as well as volcanic and hydrothermal activity. Perhaps volcanic heat could produce enough energy to support life on Titan. That's a speculation, but it can't be ruled out. However, we may not need to travel so far to discover signs of life. We may discover it on Mars, a volcanism-rich world much closer to home. Volcanoes are ubiquitous throughout the solar system. Planets such as Io Titan and Triton are intricate, volatile, and violent. Once we believed that Earth was the only planet with both volcanoes and life. Now we find volcanoes everywhere. But alien life has yet to be discovered. Volcanoes exemplify the absolute force of creation and destruction. They go hand in hand. It is true that if there weren't volcanoes here, we would not be here. Either volcanic cauldrons are the birthplace of life. Volcanoes create new landscapes, seed the atmosphere with complex chemicals, and replace the old with the new. If volcanoes are linked to the processes of life, where is life on other planets? Perhaps the origin of the answer lies in ancient times when the solar system was immature on a planet similar to our own. This is the planet Mars. 3 billion years ago, volcanoes were active. The greatest volcano in the solar system still stands. The cliffs leading up to it are greater than 6 miles in height. Even Mount Everest would be comfortable in their shadow. This is the formidable Olympus Mons. It covers an area the size of Arizona. Its crater alone is 53 miles wide. A structure of this magnitude takes millions of years to construct, a period that volcanoes on Earth never have. The Earth's crust is constantly in motion. In the depths of the Earth, a solitary hot spot forces magma to the surface, creating a new volcanic island. While the hot point remains stationary, the surface is in motion, and the new island moves away from the hot location and is replaced by a new volcanic island. Mars is different. The crust is locked solid on Mars. There is simply no tectonic activity. The crust is one big solid plate, so if there's a hot spot, it just sits there and builds and builds and builds, and you get a larger and bigger volcano. Therefore, Olympus Mons is so enormous. Today, Olympus Mons is an icy remnant of a distant, warmer era. Olympus, an extinct volcano on a fading planet, is now a veritable colossus due to Mars's diminished atmosphere. However, the ancient volcanic terrain of Mars could one day support life. The evidence is readily available on Earth. Volcanoes in Hawaii have formed enigmatic tunnels known as lava tubes, which are formed when rivers of molten rock rush into the ocean. Lava tunnels are formed when there is an underground river of basaltic lava magma and molten rock at 2000 degrees Fahrenheit. Imagine it as an icy river with a crust of ice forming on the surface. It's the same, except here the crust is solid rock and the river continues to flow beneath, creating this cave. This lava conduit and the recent images imply that Mars volcanoes may have also created lava tubes. Any rocky planet with basaltic volcanism will likely contain lava pipelines. Now, after possibly millions of years of inactivity, these lava tunnels could revive life on the red planet. This existence will be our radiation, which will be one of the obstacles that future humans will face when attempting to live on Mars, especially during solar cyclones when the incoming cosmic rays can be lethal. The tunnels and caverns of Mars's extinct volcanoes could one day serve as an ideal home, retaining air and shielding us from harmful radiation. A long-dead volcano could help fill a world with new light. Volcanoes are capable of both destruction and creation.